The loudspeaker and microphone were both invented well over a century ago, and their basic design has changed very little since then, though they may look different today. Both are transducers, which means they change one energy type into another. A microphone transfers sound energy into electricity, and a loudspeaker transfers electricity into sound. Let's look at a simple loudspeaker first. At the heart of the loudspeaker is an annular permanent magnet, not the shape that you are used to seeing. Annular magnets are not bar, but ring-shaped. In a bar magnet, the ends of the magnet have opposite poles, but in an annular magnet, the central core has the opposite pole to the cylinder surrounding it. These are the main parts of a loudspeaker. A cardboard cone, called a diaphragm, is connected to a tube with a wire coil wound around it. You may recognize this as a solenoid. The wires carry the oscillating AC input. The coil fits snugly into the circular cavity of the magnet. This is the rest position when assembled with no input signal. The loudspeaker works by the motor effect. When a current flows in the solenoid, its magnetic field interacts with that of the permanent magnet. Depending on the direction of the current, the solenoid and the diaphragm with it are either pushed out of or pulled into the annular magnet. This creates a compression wave moving with the same frequency as the input electrical signal, which spreads out as a longitudinal sound wave. The output frequency matches that of the input AC signal, and the loudness or volume depends on the magnitude of the voltage of that signal. Higher voltages cause a larger motor effect. Headphones or in-ear buds are just a small version of this design. Now let's look at a simple microphone. A flexible membrane is attached to a solenoid, which slips over a cylindrical permanent magnet. When assembled, it looks like this. Some of you might be thinking, this looks a bit like a loudspeaker, and you would be correct. An incoming longitudinal sound wave causes the membrane to move backwards and forwards. This moves the solenoid to and fro over the magnet. This generates a small electrical current in the wire coil by electromagnetic induction. As the wires of the solenoid cut through the magnetic field lines, electrons are made to move. This can also be called the generator effect. As the direction of the motion changes, then so does the direction of the current, so the output is AC. The output frequency matches that of the incoming sound signal. This signal is usually very weak and needs amplifying before being passed on to a loudspeaker. You will have seen that a loudspeaker and microphone share a very similar design, and indeed you can use a loudspeaker as a microphone if you wish, but it isn't that good.